Hello everybody, so welcome back to another video, and from here on we will be starting a binary search playlist. And in this playlist we will learn about the binary search, and later on we will solve some of the most asked question in the interviews and very important questions. So this is what we will be doing in this complete playlist, and it will be around 10 to 12 videos. So let's just get started. So first of all, binary search, so it is a searching algorithm. So if we are given something like an array, so for example 2 3 6 9 and 11, and it is a searching algorithm, and it searches for a particular key in a time complexity of log n, right? We have also have a linear search algorithm which searches in a O of n time, and there are certain others algorithms as well, but let us just focus on binary search right now. So what we will be doing in binary search, we have a low which will be pointing to the first element, and we have a high which will be pointing to the middle element. So what which will be pointing to the last element. So what we do is we find the middle element and we check whether my element is whether my element lies on this side of the mid, so this is the mid, or my element lies on this side of the mid, right? So if my element lies in this side, so my low will be here, or if my element lies this side, so my high will be here. So this is the basic idea about binary search. So can we apply, so for example if I have something like array something like this, so can I apply binary search here? So the answer is no, I cannot. So binary search is applied only on sorted arrays, is applied on sorted array, right? So this is one of the important conditions, but not on sorted arrays as well. So I can more importantly say a monotonic sequence, right? So a sorted array will be a monotonic sequence. So for example, if I have something like 0 5 13 21 and 30 and 33, so this is like monotonic, like it is increasing monotonically, it is increasing, so it can be applied on a monotonic sequence, right? So now let us just see. uh, so the basic algorithm is, so if I have a array, let us just make a array and try run this. So let us suppose it is 3 9 11 13 17 22 and 25, and the element I am searching for is like 22. My x is 22, 22 is the one I am searching for. So this is my low, 0 1 2 3 4 5 6, and this is my high. So what will be mid? Mid will be low plus high divided by 2. So it will be giving me 0 plus 6 divided by 2, which will be 3. So this is my mid. So when I find out my mid, I'll check whether the element at index mid is my element. So the element is 22 and element at mid is 13. So 22 is greater than 13, so that means my element is lying somewhere over here. My element is lying somewhere over here, this side, right? From it is might be 17 is on index 4, index 5, or index 6. So in that case we will just increase our low, and if it was on this side, so we will just decrease the high. So now my low is this, and my high is where it was. So this time my mid will be 4 plus 6 divided by 2, which will be 5, and we check is ARR of mid, that is 22, 5 is 22, yes it is. So we can return yes, the element is present, and we will run this loop till my low is less than equal to high. So if we discuss about the pseudo code, let me just code it on the IDE. So we have make this file name binary search.cpp, and let me just close the other files in main. And what I have given for example, I have given the size of the array, and I have an array. So let me just take a vector, we will import the header file later on. So vector of int vec, and it will be of size n. So for int of I equals to 0, I less than n, I plus plus. So I'm taking in the values, right? Now int key is the element I want to search, so int key, c in key, and now I want to search, so my low will be the index 0 and my high will be the last index. So while my low is less than equal to high, what I will be doing, I will be finding mid. So int mid equals to low plus high divided by 2, and if my vec of mid equals to key, I'll see out element found, right, and I'll just break out of this loop. Else if my ARR of mid is greater than key, if this is the case, I know like the element is on the left of the mid, right? So my high will be equals to mid minus 1, else low equals to mid plus 1. And if I don't find any element, so let me just take a value flag equals to 1. If I found the element, I will mark flag equals to 0 here, and I'll write a condition. If not flag, see out element not in the array, right? And just to return 0, let me just import the header file for hash include vector. So if we run this, binary search.cpp output binary. Okay, so the array is ARR is not defined, so it is vec. Run this. So same 6 2 5 8 10 12 and 19, and the element I'm searching for is 2, so element found. So this is the basic code of the binary search algorithm, and the time complexity is O of log n. How? Let us just have a look. So time complexity of log n base 2. How? So suppose this is my first element, this is my last element, I'm searching, right? So if I don't like, I'm dividing it into mid and then I'm searching this mid part, then I'm again dividing into mid and searching this mid part or this mid part, right? And same here. So this way I'm just from n I'm going to n by 2, from n by 2 I'm going to n by 4, from going to n by 4 I'm going to n by 8, and so on, right? So if you know how to solve recurrence iterations and all those, so you can find out like it is a log 2n, right? So this is the time complexity. So let us just discuss about another a question which is asked in interviews. So the question is,
I have been given an array, so I am given an array, it is a sorted array, and I need to find whether the element is present or not. But the catch is,
like, the array is infinite. Array is infinite. So the thing is like, before we knew my like low will be at 0th index and high will be at n minus 1, but now the thing is the array is infinite. So how do we determine which will be our low, which will be our high? So the problem is how to tackle this thing infinite, right? So if I have to find 10, so how do I solve this? So suppose this is my high, this is my low, and this is my high. So how do I approach this question? That is the thing here. So what I can do is I can compare my high value with this. So since this is greater, so I know it won't be on this side, it will be on this side since 10 is greater. So what I'll do, my low will be at high and I'll take my high here. Now again I check, okay, 6 is smaller than 10, so my low will be at high and high will be at index number 0 1 2 3 at index number 6. So like I'm increasing it into 2 times, right? So 0 1 2 3, it will be 4 5 6, it will be at this index. Now I'll check, is 10 greater than 15? Yes, 10 is like not greater but smaller. Now I'll apply the binary search. So this way I can do this. So let's just code it and see. So I'll just write the function for this one. So okay, so for example, I'm given an infinite array, so my low equals to 0 and my high equals to 1, and I've been given a key, int key, which I've like taken. Int key is equal to 22 for an example. So what we will be doing, while key is greater than ARR of high, right? So low will be equal to high and high equals to 2 into high. I'll move. After that, I'll apply the binary search on my ARR low and high, right? So it will give me some answer. Int answer equals to this binary search, and this will be my binary search algorithm. Void binary search, I'll be having a vector of int and ARR int low int high, and this will be my code for binary search. So what I'm doing is like right, I'm searching for like in which search space my element will be. So I'm searching for, if this is my infinite array and I'm starting from these 2 points, I'm searching and my element is right here. So I'm checking like, does it appear in this search space? No. So I'm increasing search space. So then I'm checking, is it in this search space? It is not. So I'm again increasing search space. Is it in this search space? Yes, it is in this search space. Then applying the binary search, right? So the time complexity will be again log n, I would say, if I generalize it. And there is another like I'm increasing it 2 times, like 2 into high I'm doing, so I can say 2 into log n every time, or log h, right? So that will be the time complexity. So thank you for watching this video, and I hope so you enjoyed it and learned something. So in the next video we will be doing some basic questions, like we will be doing some easy questions first, like 3 to 4 easy questions. Then we will go to some medium questions, like 4 or 5 medium questions, and some hard questions as well, right? So these questions will be a mixture of leak code and interview bit. So thank you for watching the video, and let's hit that subscribe button and do like the video for